Hello students. In the last video we discussed queues, introduction to queues and NQ operation example we saw. So in this video we'll see one more example to understand the NQ operation better. Let's take again the queue. Let's say this is our queue object. It is an abstract data type we are using. Abstract data type, this abstract data type is created by using a structure. We are going to see the code for this in the coming videos. So in this queue object, I have this array in which I'll be placing the data. Let's name it as data array 0, 1, 2, 3, and 4. So let's say the size of this array is 5. As the array starts from 0th location, the last location will be 4. And we have two variables as we have seen. The front variable keeps track of the element which has come in first in the queue, and the rear element will keep track of the rear element or the last element, so that the insertions will happen from rear side. So the insertions or NQ will take place from rear end, and the deletion will take from the front end. So as this queue is just now created, we will initialize this queue by setting f equal to -1 and r equal to -1, indicating that the queue is empty. So let us perform NQ 2, 7, 70 and 80. So the NQ algorithm we saw, the NQ algorithm is very simple. Before performing any NQ operation, we should check, is the queue full? Right? We will ask the first question, is queue full? Right? So there will be two answers of this. Right? The first one is yes. I'll write it on this side. Yes, or let me write on this side only. There will be two answers. The first one is yes, the queue is full, and the other one is no, queue is not full. What is the queue full condition? Queue full condition is this rear is storing the last location of this array, indicating that the last element is present on the location number 4, right? So that means if rear is 4, there is no space left inside this queue. We cannot insert more element in this queue. That's why queue full condition is rear is equal to this last location, in this case 4, right? Rear is equal to 4. That's correct, right? And the queue is not full means rear is not equal to 4, right? Rear is something else, it's not 4. That's why the queue is not full. Now when the queue is not full, our NQ operation will initiate. We'll insert the element inside the queue. Now when the queue is not full, when the queue is full, the situation will be like this. I'll show you the situation quickly here, right? So we may have a situation like this. F R, it's a 2, 3, 4, 5, 6, right? This is one situation where f equal to 0, r equal to 4. The 0 index 1, 2, 3, 4, right? This is one situation where rear is storing, rear is pointing to 4. It's not pointer actually. Rear is a variable, r is a variable which is storing the index of this array. These are the indices. Yeah? So rear is 4, that means the queue is full. This is one possibility. Other possibility is when we perform some dequeue operation, right? And the front may be 0, 1, 2, 3, 4. Front may be 2, right? So we may have 10, 20, 30, and r is equal to 4. In this situation also the queue is full. We'll see later how the queue is full in this case. This is a linear queue actually. In linear queue, whenever this rear is equal to last location of the array, the queue is full, though we have space from the beginning. And in fact, that's the drawback of this linear queue, which we'll see later. But for now, If we have this situation, whenever this R is equal to 4, no matter whether F is 0 or F is 3 or F is also 4, right? No matter what F is, but if R is the last location of the array, the queue is full. Sorry, sorry for this. Now, when the queue is not full, there are two situations when the queue is not full. I'll show you those two situations, right? So if the queue is not full, there are two possibilities. What is the first possibility? The first possibility is the queue is like this only, exactly like this, right? So the first possibility is like this only, where the queue is empty. F is equal to -1 and R is also -1. This is the first possibility. When the queue is not full means the queue may be empty, right? The queue may be empty, which is this case. And the other possibility is like this, right? We may have some elements inside this queue. So F and R. F is, let's say we have these elements. So F in this case will be 0 and R in this case will be 2. This queue is not full. That means it may be empty or it may be partially full. It may be partially full, right? But there is space in the queue where we can insert, right? So these are the two situations, right? And we should take care of these both situations, right? We should see which situation I am in currently, which situation the queue is in currently, right? We should check that, right? So the first situation is queue empty, right? If the queue is not full, then the next question we will ask is queue empty? If here, I'll ask after this, no, I'll ask if queue empty, right? After I get answer queue is not full, then I'll check if it is not full, then is it empty, right? If the answer is yes, this is our situation. Yes, this is our situation. If the answer is no, this is the situation, right? No, queue is not empty, right? If the queue is empty, I'll have this situation, and if the queue is empty, this situation. If the queue is not empty, this might be the situation, right? Partially full queue. Now, let's start our insertion here. Now, in order to insert 2, right, I'll follow these steps. Right? If this is the case, that means queue empty, what will I do? I will simply set F is equal to 0, R is equal to 0. I'll go to 0th location inside this data array and insert or enqueue on a 0th location, right? So why on 0th location? Because this element which I'm inserting in the queue is going in the empty queue and it will go in the 0th location, on the 0th location, right? So, and this is going to be the only element in the queue. So that's why F will be 0 and R will also be 0, indicating that this is the element which has come in first and it is also the last element, because there is no element inside, no other element apart from this element inside the queue. So that I will do if the queue is empty. If the queue is not empty, that means it's partially full. In this case, what will I do? I look only at R and I'll increment R by 1. Why R by 1? Because R stores a location of the last element inside the queue, and the next element will come on the R plus 1 location. If R is equal to 2, that means the element is present on location number 2, right? So the next element will come on location 3, that is R plus 1. That's why I'll increment R by 1 and then go to the array, right? In this case, if I increment R, R becomes 3, right? And go in this data array at 3 location and insert on location number 3, right? So the point here is, when I do enqueue operation, I look only at rear. I'll use rear because that's the end we saw in the previous video. The people enter the queue from rear end only, right? Same here. Now to enqueue this, let's follow these steps. So enqueue 2. Now let's follow these steps. Is queue full? First step, is queue full? I'll check. How will I check if the queue is full? Check the value of R. R is -1. That means R is not full. The queue is not full, right? When the queue is not full, I ask another question. Right? Is queue empty? Is queue empty? That question I'll ask, right? Again, full, no, uh, right? Full, I get no. And here I ask, is empty? I get the answer no, right? The answer is no. And if the answer is no, this is what I should do, right? Simply increment R by 1. R is equal to R plus 1. What was R? R was -1. Oh, I'm sorry, in this case, the queue is empty. I'm sorry for here. The queue is empty here, right? So the queue is empty here. Let me take another color, right? So we ask the question, is queue full? We get the answer no, queue is not full, right? I ask, is empty? Is the queue empty? This is what I'm asking, right? Is the queue empty? I get the answer yes, the queue is empty. If the queue is empty, what I do? I set both F and R to 0, right? How will I come to know the queue is empty? By looking at R. If R is -1, or I can also look at F. If F is -1 or R is -1, right? So that time I'll say the queue is empty, right? So when the queue is empty, I'll set F equal to 0, R equal to 0, right? So that means I'll make this 0, make these both 0. And then I'll go to data array, right? Data of R, which is data of 0. Inside data array on 0th location, I'll insert 2. 2 goes here, right? Now to insert 7, what will I do? Right? Again, I'll ask the same question. Is queue full? Right? I'll check R. R is 0. Right? Queue is not full. I go here. I ask a question now here. Is queue empty? This time I get an answer. Queue is not empty. Right? Because R is not -1. It is something else. That means its queue is not empty. Right? So I go. I follow this path. And if queue is not empty, that means it's partially full. The next NQ or next insertion should happen at R plus 1. So I set for inserting 7, what I do, R equal to R plus 1. So R is 0. 0 plus 1 is 1. So then I go to data of 1 and I insert 7 there. So data of 1, data means data array, data of R in fact. Because R is 1, I directly wrote 1, data of R equal to 7. So I incremented R, right? I incremented R. So first I'm incrementing R and then inserting, right? The step is first increment, and then insert. First increment, then insert. That's important, right? It's not that first I'll insert and then increment. No, it's not like that. First increment R, then go to data of R and then insert, right? So let's do insert 70, right? The queue is not full, it's not empty. We'll directly follow this step. So what will I do? First I'll increment R, R equal to R plus 1. So R was 1, 1 plus 1 is 2. So I incremented R, R became 2, right? So let me make some space here. So R became 2. And then I'll go to data of R. Now I'll go in data array on R location, right? That is data of 2 is equal to 70. So 70 will be inserted here, right? For inserting 80, again the same step. Queue is full, it's not full. Is queue empty? No, it's not empty. And then I'll follow this path. Simply R equal to R plus 1. R was 2, R will be 3 now. So R will be 3. And then I'll go to data of 3 and insert 80 there, right? So if I perform one more NQ operation, let's say I want to insert 90, again the queue is not full, it's not empty, right? Then then I'll follow the normal increment, R equal to R plus 1. So R was 3, R becomes 4, right? And then I insert on the 4th location, right? If I want to insert 100 now, let's say, now Before inserting 100, I'll ask a question, is Q full? Now I check the value of R, right? R is equal to 4, which is the last location of this array, right? When R is 4, which is the last location, that means the element is present on the last location. There is no space left here, right? Right? There is no space left here. And then I will conclude, yes, Q is full. I get an answer, Q is full. And then I say, can't insert, can't insert, can't insert or can't enqueue. It is overflow, right? So that answer, that message I'll print, right? And I'll exit this operation, right? So that is the enqueue operation. I guess you got this clearly, right? Clear 3 steps, right? First check if queue is full. If answer yes, then just exit printing overflow. And if no, that means we are now going to perform enqueue operation, right? Because we have made sure that the queue is not full. And before, when performing enqueue operation, we have 2 case situations or 2 cases which we need to consider. The first case is it is the first enqueue operation or the first insertion, right? The other situation is the queue is partially full. The queue is empty and the queue is partially full, right? So these are the 2 situations. So I told you this because when we'll perform, when we'll write code for this, right? This clear explanation will help you writing the code. So we'll write the code in the next video. See you there. Thank you for watching.